We've been progressively seeing more system demonstrations on the wireless, hybrid fiber wireless systems. This has really been accumulation of the devices that have been developed over the last, say, 3 to 5 years. And now they're starting to get into the systems and really starting to see where this technology can take the next step. So our committee is really, has 3 multidisciplinary sub areas: optical processing, microwave photonics, and radio over fiber. And microwave photonics typically receives the most paper submissions. It's really because it supports such a diverse set of applications, both on the commercial side and on the military side, and it's really about improving and enhancing the RF systems as a whole. So it really has a lot more applications that it touches. So this year, the topic for the workshop is: where can photonic analog to digital converters compete? It's been probably a little bit more than a decade worth of work on photonic analog digital converters, which originally were trying to directly compete and overcome electronic A to D converters. But the A to D converters electronic have really grown faster than people may have anticipated. So where it's sort of morphed to is more of an enhancement of the electronic technology, taking advantage of where photonics is strongest, which is in the high bandwidth and in the fiber optic remoting capability. And so what this workshop's going to do is really sort of work through those types of applications, work through those types of systems to see where the photonic technology can enhance what is already being done very well in the electronic technology. Our invited speakers are really spread out over the 3 subcategories. Optical processing, we have a tutorial in this area, and he's going to be going over wavelength conversion technologies, as well as other all optical signal processing and sort of where the field has gone to. And then we have an invited speaker talking about the energy efficient arguments for doing all optical processing. In microwave photonics, we will be highlighting some of the devices that have been developed over the last few years, including some devices that we didn't even anticipate, say, 3 to 5 years ago. And these will be applied to, say, RF sensor systems. And then in the radio over fiber, what we have is really some highlights for where millimeter wave technology has been able to go. And in fact, the data rates that we're now able to get wirelessly that have been enabled by photonic technology are really rivaling what 5 to 10 years ago we thought you could only do with a wire line. And so we sort of cover all of those topics with our invited speakers, including a couple of other topics. What we've tried to do is put together a program that touches all 3 of the subtopics, that brings up a little bit of potential controversy, for instance, with the photonic A to D workshop. What we're really trying to do there is to show where photonic technology can take the next step, and also take a look at why, for instance, photonic technology wasn't able to overcome electronic technologies, and why electronic technologies were able to sort of continue on their progression when a lot of people thought it was going to tail off. So what we've tried to do is make it as broad as possible for the attendees, and I expect that the attendees will probably be able to both learn a lot in terms of getting an education from the tutorials and the invited speakers, and then the contributed papers are very strong again this year.